Hi guys. Добрий день, Lviv. My name is Denis. You can find me online as a Pixels Commander. And I started developing many years ago when I was 6 years old. My father brought to me a Soviet clone made in Belarus, Soviet clone of ZX Spectrum, which was quite amazing piece of technology. And there were some games running in it. One of the games was Manic Miner. And since presentation is about mining, I decided, okay, let the whole presentation be decorated in the style of Manic Miner. Oh, this was in 1991, many years ago. Then, with the time, I progressed as a web developer, and spent a lot of time on computer graphics development and also on performance optimizations. Currently, I work in a company called Evolution Gaming, making photorealistic games with React and WebGL. Quite interesting project. So I was looking for such for a long time. Not that many companies invest that much. It's gambling, but not that many companies invested much into WebGL. So company really bet on WebGL, and we do really crazy stuff there. Before that, I was working for 4 years in a company called Liberty Global, which is the biggest internet provider in the world, like a huge corporation owning many internet providers, like Virgin Media. If you ever heard Richard Branson company, is a part of Liberty Global. So we've been delivering software for set-top boxes, for TV boxes for Liberty Global, which is a box you connect to TVs, and you have some applications, of course, video, TV channels there. And then the problem was the company bought boxes which are not capable to run software which was designed for them. The software was JavaScript-based operation system. So then 4 years we've been optimizing JavaScript-based operation system to be able to fit into the performance window of these boxes which we already own and our users already have. So I'm quite into performance optimization. I was running a masterclass on performance optimization. So now we have technologies like React Native, and the demand for hybrid web applications is a bit lower, but then back a few years ago, it was very high. So this masterclass was quite successful. And many friends of mine know that I'm a font. I'm really addicted to optimizing performance in the browser. And once, a friend of mine who has some money. This talk is about money and about performance. He asked me, Denis, do you want to mine some crypto in browser? I think this is possible, and I know that you're the right person to try mining in browser because you know so much about how to make browser working quickly, working fast. For me, it sounded like, hey, do you want some performance challenge? And I accepted the challenge. So I recognized mining as a bleeding edge performance challenge for the web platform. So who knows why do we need mining and how it works? Okay, there's few people out of the room. Let's go into basics. Even the hype was there, so the mining itself still have a bit of a mystery. So why do we need to spend all this energy to get bitcoins? Okay, so we all know that bitcoins, cryptocurrencies, are built with a blockchain. And a blockchain, as it goes from the name, it exists from the blocks. Every block has some information which is useful for the cryptocurrency, for the network, like for user information. For Bitcoin, it's from, to, and amount of money sent. Then there is some system information, like a hash. Hash is a quite important concept, so let's see what it is. Hash is a fingerprint of a block. So once you changed a bit in a block, like a single character, hash changes. So every block have unique hash, right? It's very important to understand. Then we have hash and hash the previous block. Then with hash previous block, we have this chain like linking, like linked list. to hash, to hash, to hash. Okay, and that network, blockchain network, is decentralized. It means there is no single authority managing network. So there are some nodes which can manage it. What if we want to add a new block? Because this is essentially how we spread information over a decentralized blockchain network. If we want to add a new block, then anyone can do that. If there is only one single guy who would like to do that in the moment, then everything is fine. But actually, there are a lot of nodes who pretend to insert the node. So how this problem is solved? Yeah, then you might get into trouble. This problem is solved with a mechanism called proof of work. So you do some calculations, you solve some mathematical problem, and then if you are successful in solving it, you provide the solution to the network, and network rewards you with some cryptocurrency because you helped the network to run further. You basically did quite useful thing for network. It can't exist with the people without the people who mine. All right, from the theory, the short dive, let's go to a practice. First I tried, of course, was the mining Bitcoin, mainstream stuff, right? How do Bitcoin mines? We remember the concept of hash. And for Bitcoin to have a block valid, to have the problem solved, it needs 18 zeros in the beginning of a hash. It's a quite unique thing for hashing. Bitcoin uses SHA-256 for hashing blocks. It's quite well-known algorithm. There is an article on Wikipedia how it works. So if you're interested, it's very transparent. There is nothing secret. And the mechanism, the thing which allows to mine, is a field called nonce. So how mining happens essentially? We have a block. Then we put a nonce equal to 0. We have a hash of a block after that. Oh, there are no 18 zeros in the beginning of a hash. Next one. Then we put nonce 1. Other zeros? No. Then the nonce 2, and so on, and so on, and so on. So to get a right hash, it is 1 in the power of 20 chance. So you need to make 1 in the power of 20 hashings. I even don't know the name of a number, which is it. But it's quite a low chance. One single computer can't do that anymore. And miners basically join interpools. So let's consider that your website or application work as a pool. And we mine with your users, not injecting, but just putting some piece of JavaScript into their browsers. How pool works normally is then few miners connect to some server, and servers say, you mine nonces from 0 to 10, you from 10 to 20, you from 20 to 30, and so on, so on, so on. And then you are being rewarded. Once the right solution is found, you are being rewarded equally to the number of calculations you did. Okay, so mining Bitcoin in browser. Time for Manic Miner. That's an interactive application where we have a few fields. So first of all, we can select the way we mine. We see how many hashes per second the current way of mining do. And we can enter a number of users who are currently visiting a website. Then in the end, we will get, zoom it out a bit. We will get euros per month we get from this way of mining. Okay, the first one and the simplest one is a JavaScript miner. We just have a block, some information in a JavaScript object. We have a hash of it in the SHA-256. So let's start. We see this is 42,000 hashes per second. And then when one user is mining, we have 0 euros per month. Let's see how it changes with the number of users. 100 users mining, 1,000 users mining, 10,000. Okay, 1 million users mining will bring you nothing in a month. But, you know, I initially knew it's going to be hard. I never thought the mining in a browser is going to be easy. So, never give up. Next step. I thought, okay, let's optimize JavaScript. So that's what I normally do. I optimize JavaScript or I optimize rendering. I was considering, is my hash implementation slow? No, actually, hash implementation was okay. It is not normal that initially, from the first try, you get the fastest library. So normally you have a lot of shit and then you get, oh, this is brilliant. But not in this case. So in this case, actually, I got, on the first try, the library called Forge. And based on all benchmarks, the Forge is the #1 on performance SHA-256 algorithm. So my hashing algorithm was completely okay. And it was something different. The problem was different. Maybe web workers can work better because on a CPU we have a few cores, right? And then only one works for main thread, and then the rest is just don't give a fuck. Okay, the time for Manic Miner. So we select a web worker miner, which is basically doing the same thing with the same hashing library, but then just in a parallel. Also, the interesting thing, if you've been never working on parallel JavaScript, I'll zoom in. So in the window navigator, there is a variable which is called hardware concurrency. And it actually works, and it gives you the number of cores which are available for running web workers. For me, it was a new thing. So to be honest, it is the first time I was trying to optimize web workers for full. So I'm using this hardware concurrency to get the number of web workers I'm going to run here. All right. So any ideas on how many hashes per second we will get with web workers? 200,000. Okay, last time it was 40. Let's check. Bingo! It's actually 200,000. And then let's see, 1,000 users. Oh my God. So basically, the improvement is not that good. But still, never give up. Let's optimize further. What about WebAssembly? So WebAssembly is a quite cool thing, quite fresh, and it promises nearly native performance for a web platform. And many people are excited about WebAssembly. WebAssembly will change the landscape of technology. Maybe it will do. So time for Manic Miner. Right. Any ideas for a WebAssembly one? Okay. You remember your bets? Then let's start. Oh, actually, WebAssembly is faster than JavaScript, but not that much. Like it's quite comparable. I can imagine that we can run WebAssembly in web workers, right? Then it might be quite efficient. Like we will get 500,000 of hashes per second approximately. But then, to be honest, it's not what I'm aiming for. With 1 million of users, I can do definitely better in terms of mining. Okay, so never give up. Going further. I heard mining on GPU is fast. I heard that these major miners who are making a lot of money are really making the whole world starving of GPUs. Like buying a GPU for a gaming PC was incredibly hard like a year ago because everybody was buying for mining on GPUs, right? Okay, and it happens for the reason that CPU, yeah, now we have CPUs with a few cores, but it's still like up to 8. But GPU is incredibly multi-core and doing everything in parallel and very quickly because it's designed especially for mass. Like all you see on a screen when you play a computer game, that's a mass. Basically, metrics modifications and it's calculating how point is getting from one point to another with some trigonometrical formulas. Then, how we can mine on GPU? We can mine with pixel shaders. That's a quite interesting topic on itself. I have another talk about how to write the first pixel shader, and it's quite interesting because you can do not only effects or mining, you can do also UI components with pixel shaders. And yeah, it's on YouTube. Maybe you'll get interested. So how pixel shader works? You have a canvas with WebGL context created. Oh, for example, a canvas of 7 by 4. And on every pixel, you start a program. It's a program which is written in a language called GLSL, OpenGL shading language. It's quite similar to C. It has strict typings. What's happening? Well, you can have this text in JavaScript in any way. You can get it from the server. You can get it from a tag, or you can have it just hard coded as a string. You send it to a driver of GPU. Driver compiles it to a machine code, which is then being executed by GPU. So this is the most low-level way of doing calculations, the closest to the hardware you can even imagine in a browser. Basically, this is a special device designed for mass. It's being executed without any virtual machine, with the machine code directly, and it executes for every pixel. Or, for example, we say the whole thing like, hey, canvas, your first pixel have a nonce of 435. Then canvas knows, so every pixel, when it executes its shader, it knows its coordinate to the beginning of coordinates. So then we can consider that the second one is 436, and then 437, and so on, so on, so on. So basically, every pixel we made a hash operation on a block, and then once pixel is correct, we highlight it with some color because it's a canvas. So what we can do with pixel shader, the only way we can get a result from pixel shader from all this operation, we can say, okay, I'm white pixel. It means that you got correct nonce. It means that you got correct block and a lot of money. So time for Manic Miner. Any bets for WebGL stuff? 1 million. Okay, bets accepted. What? We can try, of course, but we all know the basics of the mess. Oh, never give up. So, okay, I can explain what's happening. So, we've been discussing how all this being read from the canvas, and it's actually have quite an overhead of JavaScript. If you think about that, this canvas have a lot of pixels. Oh, this one is just for a demo, but normally you would create like a canvas of 1000 by 1000 pixels. It makes sense. Like normal canvas, why not? Then it's going to be 1 million of pixels. And what you do with JavaScript when you want to read the result of shader execution? You go through every pixel and you read, you know this get pixels thing. So basically, you do your JavaScript 1 million times, checking what's the color of JavaScript, and it's quite an overhead. So what if we calculate not one single nonce on a pixel, but what if we calculate 1,000 nonce? It means that this JavaScript overhead is going to be decreased by 1,000 times. Time for Manic Miner. Whoa, whoa, whoa. It's 8 millions something hashes per second. So we are 200 times faster than initial implementation. And we still have nothing. Never give up. All right, what happens? What the hell? So the problem is that the evolution of mining tooling is happening for years, so for Bitcoin. And initially it was a CPU. That's what we tried with the JavaScript. First we started with JavaScript, we tried to mine with a central processor unit. It works. It's quite slow. Then the mining moved into GPU era. A single GPU, like GeForce GTX 960, which is not that amazing. It makes 1,600 threads in a parallel. So it works approximately as 1,600 CPU, or maybe even faster because it's optimized for mass. GPU is cool. Yo. Don't say others. But then some clever people decided, okay, why do we need GPU? Because it's a universal expensive unit. Then we can make a small chip which is going to make a single possible operation for him. Here. ASIC. ASIC is a thing which as fast as 20,000 GPUs. GPUs. So can you imagine how the evolution came through all these devices and how it's different now from mining on CPU? It's basically impossible to get something there. From GPU you got some bits, but it's also really impossible to compete, and it doesn't make any sense because you will spend way more energy just on calculating on GPU comparing to calculating on ASIC, which is designed only for one thing, making SHA 256 and saying, is the hash have 18 zeros? That's it. So yeah, that's the thing. It's ugly. You can't play games on it. You can't run JavaScript on it, but it's there. Yeah, but the mining is broken for the first generation cryptocurrencies. Then the second generation cryptocurrencies fixes this actually. Ethereum is ASIC proof. You can't mine with ASIC. You can't develop ASIC for Ethereum. It's impossible. But there is a problem. I tried to mine Ethereum. And the problem is that Ethereum algorithm has been protected from ASICs by requiring 3 gigabytes of RAM or video memory to mine. That's why to mine Ethereum, you need a 3 gigabyte VRAM GPU. And it's basically not possible to allocate 3 gigabytes for WebGL sync in the browser, unfortunately. So Web is failing in mining Ethereum. But never give up. Alternatives. You know, there are a lot of altcoins. As the whole market is quite interesting now. Some currencies are dropping, some increasing. So it's all alive, and there is a currency called XMR Monero, which is not that bad, and it's designed especially to mine on CPU. It's ASIC proof, and there are some good bits on it. It's constantly increasing in the price. And then also, good bit that for Bitcoin, if you think that it's anonymous to make a transaction in a Bitcoin network, it's not right at the moment. So FBI definitely can they anonymize transactions for Bitcoin in some way. But Monero is more protected up to date. So recently, FBI started a contest on hacking and de-anonymizing Monero protocol. And the cryptocurrency is doing well. So let's mine this Monero algorithm, which is designed for CPUs, and it's probably a way better match for our Manic miner. But one thing, don't look into hashes per second, for the reason that the algorithm is different. So let's start. But look into euros per month. And this is a single user. And here I can quit my job. Here I can help my parents with building a new house. Definitely. And if you have 100,000 users, I'm not sure what I will do with all this money monthly. But it's real. Like all these calculations are based on a real productivity and real value of a cryptocurrency at the moment. So, mining Monero is possible with JavaScript. It's possible to do with your users. Then, how you can do that? There are some plugins for that already. A year ago, there was nothing. Now there is a CoinHive. Oh, CoinHive is amazing. Oh, let me give you an idea how it works. It's really simple. So you just put a script onto your web page or application, and then you create a new miner with an API key, and you start mining in your applications. Then you have a dashboard where you have a number, how much money you got from your users, how long they've been mining, and so on, so on, so on. It's really simple. There are a lot of customization options, like how much of calculation power of your CPU, of a CPU of your user you are going to use. Because if you use 100% of CPU, it's really bad for user. It's really bad for your user experience. Then if you use only 30%, it's okay. There is another thing called CoinImp. I'm not sure how these guys actually survive, but their selling point is zero commission. And essentially it's the same as a CoinHive. This project is different. CryptoNoter is a thing which is a whole platform open sourced. This is a repository or it's an organization or on a GitHub which have a pool and a miner and all the things you need to mine Monero, and you can build your service like that with a CryptoNoter. So there are tools, there are some money, it's possible. Why you might like to use this one? So there are some cases when advertisement to monetize your resources is not acceptable. So for example, there is a website, some people might use it, it's creativeapplications.net. So this website is all about aesthetics. And at some point they realized that monetizing with Google Ads just breaking their aesthetics of a website. So what they do? They mine Monero on the website. Many people worldwide using it. There are a lot of adepts, fans of this website. Creativeapplications.net is amazing. It's all about new media design. It's making masterpieces with the new technologies, also coding. And it's critical for this kind of people. I want to have a beautiful page because I see beautiful things on it. So I want to be safe from ads about buy Viagra or whatever. Oh, they transparently show a dialogue in the beginning. Hey man, we are going to mine with your laptop. Are you okay with that? Because we need some support. We need to run our website and we need money. So you can click no. Means it never happens. But if you click yes, it just utilizes 30% of your GPU. And in this way, they monetize their website. And there are many more projects doing that for different reasons. Some have ideology reasons, like we are not going to pay Google or work with Google. Some have reasons of aesthetics. Some just doesn't like ads. But some projects just have both ways of monetizing. Nobody actually restricts you from having both ads and mining. But then what we should think about also is how GDPR and all laws to protect privacy are changing advertisement. Efficiency of advertisement is dropping a bit. Oh, nobody knows what's happening in a few years. And mining is basically already there. So the biggest problem is ethics. So, first of all, I already mentioned, you shouldn't mine with 100% of a CPU or resources of a user, right? Then mining on mobile devices, it's not that good idea. So mobile devices are mining well. They're quite powerful nowadays, but then the problem is the battery. And if user reads your article for 20 minutes and then he found himself without a battery in the middle of nowhere, you're going to be responsible for that. So if you're using CoinHive, for example, you can put a simple condition, like if user agent is Android or iOS, then we just keep it. That's it. It's very easy. And of course, transparency. Transparency is very important here. Otherwise, it will start being blamed, the whole stack. So far, I don't think that many people are really blaming this thing. It sounds a bit nasty to mine in a browser, but if you think about that, it might be even better or more fair than ads. Maybe. Money you've seen. Like, there are some money. Not sure is it worth it for you personally, but the whole thing is here, you can use it, and it's easy. And of course, please, don't forget, this talk was about performance also. Thank you.